So good morning everyone and welcome to this lecture. Uh, as you remember and as you can see, in the last class we were discussing something known as the equation of trajectory. And what do you mean by equation of trajectory? Well, I told you trajectory is nothing but the path which a particle follows, and to find the equation of trajectory, what we do is we find either y as a function of x or you find x as a function of y. If you can do that, that gives you the equation of trajectory. Do we remember this? Yes or no? Okay, then I think I gave you a question wherein you had to find the equation of trajectory, and the question was looking like this: x is equal to 2t square and y is t cube. You have to find the equation of trajectory. Anyone could do this? Anyone could do this? Yes or no? No one? You have to find the equation of trajectory. No one could do this? Shall I do it now for you? Okay, I'll do it then. How do I find the equation of trajectory in this case? Well, it's quite simple. What I need to do is I need to find y as a function of x, or I need to find x as a function of y. Basically, I have to find a relation between x and y. Now, how do I find relation between x and y? How do I find the relation between x and y? So basically, what I need are x and y. What I don't need is t. I don't need t. I need x and y. So basically, that simply means that I need to eliminate t from the equations.
Hello. Sir, my voice is audible? Chintal sir.
Yes, sir. Yes, sir. You're audible now. Yes. So basically, what we got to do is to eliminate t between the two equations. Now it is a simple case of just eliminating t. So what do? I write the first equation, x is 2t square. From here, I can get the value of t. T is x by 2 raised to the power 1 by 2. Or you can call it raised to the power half, or you can call it root of x by 2. Do we understand this? I look at the other equation, y is equal to t cube. From here, I can write t as y raised to the power 1 by 3 or cube root of y. I have got t on the left hand side, I have got t on the right hand side. What I am going to do? I am going to equate the two t's. X by 2 raised to the power half is equal to y raised to the power 1 by 3. This is the equation of trajectory in this case. Now it may not look very good in this way. So what do? I raise everything to the power of 6, because 6 is the LCM of 2 and 3. So I raise everything to the power of 6. If I raise everything to the power of 6, the equation that I have is x by 2 cubed is equal to y squared. And you can write this equation in this form, or you can write it in the previous form. This is x as a function of y, or y as a function of x, no matter how you look at it. This is the equation of trajectory in this case. So basically, equation of trajectory means you have to find an equation between x and y, a relation between x and y. How do you do it? You just take t from the equation out and you are done. Do we understand this? Yes or no? Everyone in the class, do we understand this? Because once I have told you how this is done, you will have to solve the next equation all by yourself. and find the equation of trajectory in this case. Shall I give you the question? Yes or no? Anyone? Boys, do we understand this?
No, sir. Wait, sir.
Okay. Take your time. Let me know once you are done. If you have any doubts, please ask. What we have done here is we just eliminated t from the equation. Simple maths, no complications. Simple maths is simple.
Done, sir.
Done, everyone? Okay, I hope you can do the next one. So this is the next problem. X is equal to 80 and y is equal to not 80 square, it should be bt square. So y is bt square and x is 80. Can you find the equation of trajectory in this case? I'll give you 2 minutes to do this.
T equals to x by a, sir.
You have to tell me the equation of trajectory, bacha.
X by a whole square is equal to y by b, sir.
That is correct. I think, yes, that is correct. Well done. Remember, we need equation of trajectory. We do not need t. We do not need the value of t. We need the equation of trajectory. We need the equation of trajectory, my dear friends. I'll give you 1 more minute to do this.
Sir,
Yes, beta.
a square y is equals to b square bx square.
That looks good. What about the others? Are we able to understand this? I can't see you, so I hope that everyone is able to do this. Remember, we only need to eliminate t from the equation, and I think eliminating t from this equation is pretty simple because I can write t as x by a. Once I get the value of t,
X by a whole square is equal to y by a.
I can just put the value of t here. So basically what is going to happen, my dear friends, you are saying it correctly, my y becomes b into x by a ka whole square, and that is the equation of trajectory, my dear friends. Do we understand this? Yes or no? No, yes. Everyone? Okay, see, finding out the equation of trajectory is pretty simple. It does not require much, and it is a good question. I mean, it helps you in gaining confidence. Let us see if you can do this one. Question number 3. X is equal to ux into t. Now, this is what is going to come in the next class tomorrow. X is equal to, maybe today also, x is equal to ux into t. Y is equal to, no, instead of writing ux into t, because that will be confusing, I will write it as u cos theta into t. And y is u, why I'm writing u sin theta into t minus half g t square. Remember, theta here is constant, g here is constant. Can you get the equation of trajectory in this case? Can you get the equation of trajectory in this case? X is given as u cos theta into t, y is given as u sin theta into t, and you have 2 minutes to do this. I hope that is good enough. Just have to do simple things. There is no complication here. Simple things. 2 minutes. Yes, bacha. Anyone with any answer? Shall I do it? Remember, whenever you see a question, the first thing that should come to your mind is that the question is simple and that you know how to do it, because there is nothing that I will not tell you. There is nothing that a question will come about and you don't know about it. The only thing is how many things you can recollect and how much practice have you done. Anyone got the equation of trajectory in this case? Or shall I do it? Shall I do it?
Sir,
Yes.
Y is equals to ux tan theta minus half g x square by cos square theta.
Repeat it again. Say it again, beta. It was looking correct. Say it again. Okay, what I need to do? The only unwanted quantity here is T, T, and T.
Sir, please increase your voice, sir. Please. Please.
You're not
Please
able to.
increase.
You're not able.
Yes.
I think you won't. Do you? Can you check your speaker?
Yes, we checked our device. It's perfectly all right. Please increase your sound, sir.
I am.
It's mic sound.
I am talking at the maximum.
Okay. Let it be continued, sir. No
Just let me check. Tanaka Center, can you hear me better? Nice. I'm audible. Sir, please. I think there's something is wrong with the speaker or the settings. I think I've just checked my system. I think it is fine. Okay. You can hear me, right? Okay. So I need to eliminate T. How do I do it? Let me call this as equation number 1. Let me call this as equation number 2. I'm going to find the value of T from equation number 1. From equation number 1, I can get T is equal to x by u cos theta. Once I get this value of T from here, I will just put it here and I will get my answer. What answer am I going to get? I am going to get this answer. Y is equal to x tan theta minus g x square by 2 u square cos square theta, and that is my equation of trajectory in this case. And this equation we are going to see very soon in projectile motion. This is actually equation of a parabola. This is the equation of a parabola. The path is parabolic. When y is of first order and x is of second order, or the reverse, x is of first order, y is of second order, the equation is equation of a parabola. Similarly, this question that we did, this also was an equation of parabola. Y was 1 degree linear, x was a quadratic. This is the equation of a parabola. This, my dear friend, if you remember, this is the equation of a parabola. It is y square is equal to 4ax. It could be x square is equal to 4ay, depending on how you are looking at things. Do we understand this? Got this? And this equation we are going to deal again when we do projectile motion. Do we understand this? Yes or no? Equation of trajectory. Remember this equation, which is right now on your screen. We will be requiring a lot of this equation in time which is coming up. Let me just put a question for you. Since we are talking about equation of trajectory, if I put this equation this way, x is a sine omega t and y is a cos omega t. Or if you don't want, yes, because I have to put t. X is a sine omega t and y is a cos omega t. Can you now find out the equation of trajectory in this case? Can you now find out the equation of trajectory in this case? I'll give you 2 minutes to do this.
So y is equal to a tan omega x, sir.
Y is
A tan omega x.
Sir, y equals to cot x, sir.
how did you get it?
Yes, sir. Y is equal to a cot omega x.
Sir, hello.
Yes. This is to understand, this is inside the sine of omega t. It's not cos omega multiplied by t. It is like this. This is an angle actually. Omega into t is an angle. It's not the previous case where it was u cos theta multiplied by t. That was different and this is different. Do we understand the difference between the two? Do we understand the difference between the two? How I've written? Do we understand this? The first one, the pink one, was written in a different way. It was u cos theta multiplied by t. This is a sine of omega t. Understand the difference? Yes or no? Somewhat different. How do I get the equation of trajectory here? Shall I do it? Anyone? Okay. So from equation number 1, I can find out that sine of omega t is x by a. Yes or no? From equation number 2, I can find out cos of omega t is y by a. The problem is if I divide the two equations, I do not eliminate t. So this is of no use. So what do I do? How do I eliminate this? I square it. I square it. And then I add sine square something plus cos square something is equal to how much?
1, sir.
1, sir. So this is equal to x square by a square, sir, plus y square by a square, sir. That means I land up with the equation x square plus y square is equal to a square. Do you know what does this equation represent? when both are second order and they have the same coefficients. This is the equation of a circle, my dear friends. This is the equation of a circle. The particle is following a circular path. Do we understand this? Anyone understand this? See, remember, all these things have got nothing to do with physics. It is maths. It is purely maths, nothing else. It has got no relevance with physics. It has got no element of physics. It is purely maths. Pure maths. Equation of trajectory is actually pure maths. Maths is the language of physics. Without maths, physics cannot do anything. And that is the problem. If you are weak in maths, you become weak in physics. But I don't look at the negative aspect. I always look at the positive one. If you are good in physics, you automatically become good in maths. Or vice versa. If you are good in maths, you should become good in physics. Do we understand this? Can I give you the next one? The last one. Remember, there could be a large number of questions that could be made. I am just trying to do whatever is required, and in that domain, you must be able to get a question from there. This is the next one. Can you tell me this equation of trajectory of this particle? X is A sin omega t, Y is B cos omega t.
Sir, AB whole square is equal to BX whole square plus AY whole square.
Repeat it again.
AB whole square is equal to BX whole square plus AY whole square.
That looks correct. That looks correct. The way you have said it, it's not the way probably I will put it, but what you have said is absolutely correct. Because I will put it in a way in which you will be able to understand it in your maths class. Anyone got the answer? Anyone else?
A square B square is equals to B square X square plus A square Y square.
So I think everyone has understood the concept. From first, I will find the value of sine of omega t. Sine of omega t is x by a. From equation number 2, I will find the value of cos of omega t. Cos of omega t is y by b. I square it. This is square. I square it. This is square. I add it. And I end up with this. 1 is equal to x square by a square plus y square by b square. Here we have second order equation in both x and y, but their coefficients are different. They don't have the same coefficients. This, my dear friend, is the equation of something known as an ellipse. ellipse, parabola, hyperbola, circle, and straight lines. These are a part of your curriculum in maths. This is the equation of an ellipse. X or A is known as semi-major axis, B is known as semi-minor axis. Do we understand this, how we have done this, yes or no? Equation of trajectory is simply an equation between x and y that tells us how that particle or how the path of the particle is, as simple as that. That takes us to the next heading. We have now seen the equation of trajectory. Now let us see what type of motion fall in the category of motion in 2 dimension. We have seen general motion. The first question that we did was a particle moving randomly. Then we saw some equation of trajectory. We saw a particle moving in a circle. We saw the equation of trajectory, that is motion in 2 dimension. We saw a particle moving on an ellipse, that is motion in 2 dimension. We also saw a particle moving along a parabola, that is also motion in 2 dimension. And that is what we are going to study whenever we think about motion in 2D. The first thought that comes to everyone's mind, as soon as I say what do you mean by motion in 2D, the first thing that they are going to tell me about motion in 2D, sir, projectile motion is an example of motion in 2 dimension. Projectile motion is an example of motion in 2 dimension. Now, as soon as we say this, that projectile motion is an example of motion in 2 dimension, first of all, we need to understand what do you mean? What do you mean by a projectile? What do you mean by a projectile? Or what do you mean by a projectile motion? Anyone heard about the term projectile and projectile motion? Anyone can tell me, when do we say a motion is projectile motion? Yes?
Freely falling body is known as projectile.
Freely falling body is known as projectile. Very good. That means any motion which takes place, any motion that takes place under the action of gravity only, under the action of gravity. When I say gravity, gravity is the gravitational force of Earth. Any motion that takes place under the action of gravity only is known as projectile motion. All other forces are neglected. Even if they are present, they are neglected. Whenever we talk about projectile motion, the only force that acts on the body is gravitational force. Do we understand this? Do we understand this? All other forces are neglected. G. What is G? What is G? Huh? What is the G?
Gravitational force. Acceleration due to gravity.
But there is a difference between gravitational force and acceleration due to gravity. Gravitational force is a force. Acceleration due to gravity is the acceleration that that force produces. Both are different. Remember that. Okay. G is taken as constant, so we will always take it as 9.8 or 10, and it will be always acting downwards. It is actually not downwards. That is how we take it. Okay. And you can also write the motion is taking place, because that will come in the gravitation wala chapter. Motion is taking place very close to Earth. Now, when we say that the motion is taking place very close to Earth, why do you want the motion to take place very close to Earth? Because then only we can take G as constant. G can only be taken as constant if the motion is taking place very close to Earth. If the motion is not taking place close to Earth, actually G changes. We will see what is the effect of this G. Now, how does G change from point to point in the chapter known as gravitation? G is not constant everywhere. It changes. It changes because of the position on Earth. It changes because of rotation of Earth. It changes because of going up and going down. It changes because of a lot of things. We will see those changes in the chapter known as gravitation. Right now, we are dealing with projectile motion. Any motion that is taking place under the effect of gravity only, all other forces, even if they are present, we neglect them. G is taken as constant and the motion is taking place under the action of gravity. Now, as soon as we think about projectile motion, we will study it under three headings. We will study it under three headings. We can call that this projectile motion can be of three types. Nah? Three types. Anyone, any idea? What are those three types? Any idea? What are those three types of projectile motion? The first type of projectile motion is what I call vertical projectile. The second type of projectile, if one is vertical, what is the second type? The second type would be horizontal. Horizontal projectile motion. If one is vertical, the other one is horizontal. The third one is known as oblique projectile motion. Now, as soon as we talk about projectile motion, and I have now told you the three types of projectile motion. Have you done this projectile motion before?
Yes, sir.
When, sir?
In IP we have done, sir.
When I say have we done this, that means have I done it in the class?
Sir.
Yes. Have I done it in the class? In this class? This class. Have we done it in the class? Yes. Yes or no? This is a yes, this is a no.
No, sir.
No, sir. Okay. I take your words that we have not done it. So the first type of motion, since we have not done this, will be known as the vertical projectile motion. Vertical projectile. Now, how does a vertical projectile look like? I am on ground. How will a vertical projectile look like, since you have told me that you have done projectile in whatever class you called me IP? Well, how will a vertical projectile look like? Huh? No idea? Well, the name says, I will throw something. Where? Vertically up with an initial velocity u. Whee! From point A. It will reach a point B, the highest point. The velocity at this point becomes 0. The height it reaches is h. Now again ask you this question. Have we done this before? Yes or no? Have we done this before?
Yes, sir.
That was. We had done it under the heading of motion under gravity. And that is basically a projectile motion. This, what you see here, is projectile motion. Motion under gravity. Oops, why I'm writing gravity under twice? Motion under gravity. We have done it in one dimension. So I was just throwing it vertically up, dung, 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 and it was coming vertically down, dung, 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 dung. That is also projectile motion because it satisfies all the conditions that we have written. 4 conditions. It is taking place under the action of gravity. No other forces are there. G is taken as constant. It is taking place close to the surface of Earth. This is, my dear friend, a projectile. I call it vertical projectile or projectile motion in one dimension. Dung, 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 dung. It takes place like this. Do we understand this? Yes or no? Huh? Okay. Now, if I could ask you, I had given you some formula for this. Yes or no? What was the formula for this height or maximum height it reaches? Nah? What was the formula for this maximum height of this gentleman? No one remembers it. Everyone is now going to look back. Tell me. This H max or H. Anyone remembers?
V naught square by G.
V naught? I don't see any V naught here.
V naught square sine square theta by 2G.
See, I don't see any V naught. I don't see any sine theta. I don't know which universe you are talking in. Come to this universe. This is a good universe, only 4% of which we see. But this is good. I like this universe. F is equal to ma is valid in this universe. Please come into this universe. In this universe, I have a point A and point B, and I'm throwing a ball vertically up with a velocity u. What is the maximum height that this ball attains? Yes, my dear friends. No one knows it. That means whatever we have done in motion under gravity goes down the drain, and right now it is going toward the Ganges from some drainage system. It is going down the Bay of Bengal or Ganga, and it is going to get into the Indian Ocean. Bye bye. If you remember, it was u square divided by 2g. That was what it was all about. U square divided by 2g. Now, since this motion is taking place along y-axis, instead of calling it as u square by 2g, I could now call it as uy square because this velocity, as you can see, was along y-axis. This was my y-axis. This has always been my y-axis. And this is my x-axis. This always been my x-axis. Anyways, I had given you time taken to go up. What is the time it takes to go up? From A to B. Anyone remembers it? Yes or no?
U by G.
Thank God. God exists. I always keep on asking God whether you exist or not. But when I ask you questions and you give me answers, God exists. Time taken to go up is U by G. What is the time taken to come down? Huh?
V by G.
Where is V? There is no V. Come in this universe. In this universe, there is only you. That is the only velocity that is known to me. There is no V, my dear friends. Which universe are we wondering? Come to this. F is equal to ma. Good one. This is a good universe. Yes. Try again. How much time it takes to come down? I think you have forgotten. It is the same at the time it takes to go up. I can now write it as uy by g because this u was actually along y-axis. What is the total time t? I called it the time of flight. I call this t, if you remember. If you don't remember the formula, you obviously will not remember that I call it a time of flight. But in some universe, you might remember this. This was known as the time of flight. Total time it remains in air. How much is the total time of flight? Did I tell you? Yes, bacha. The answer is right now on your board. You know the time taken to go up. You know the time taken to come down. You can't
So
tell
time
me
taken to go up plus time taken to go down.
how much will that come. How much will that come? It is very difficult to add the 2, so I will add it. 2 times uy by g. It was so difficult to do. Uy by g plus uy by g. It would have taken a lot of time to calculate you this. Anyways, I have done this for you. This 2 times uy by g. So that was vertical projectile motion under gravity in 1D. That was a type of projectile motion. I call that projectile motion as vertical projectile motion. We have already done this. You don't remember it, that's a different issue, but you can become Ghaznavis. I can't. Because if I keep on becoming Ghazni and if I keep on reminding you what happened in the beginning of the movie is going to be a disaster. The movie has to go on because life has to go on. That was the vertical projectile motion. What is the second type of projectile motion? And that type of projectile motion we call as oblique projectile motion. Oblique projectile. You can call this as motion in 2D because now motion is going to happen in 2D or in a plane. How will the motion happen in a plane? What will I do for this motion to happen in a plane, my dear friends? Yes, you have done this right now, so you can tell me how this motion is going to happen. Yes, and I wait for you. And I know that you know how this motion is going to happen. So now what is going to happen? Tell me. What is going to happen now? In vertical projectile motion, I throw the particle up. Dung, 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 dung. Dung, 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 dung. What is going to happen here? How should I throw it? Huh? This is my y-axis. You all know this. Always my y-axis. This is my x-axis. How should I throw the projectile now? I have to make it motion in 2D. How should I throw the projectile? You already done this. Tell me. No idea?
Parabolic.
Hey, how should I throw it? Forget about the path. How should I throw it? I threw it vertically up, dung, 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 pung, 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 in the first case. How should I throw it now? First things first. Let us understand how we are going to throw it first.
Semicircle, sir.
Hey, how should I throw it? First, I threw it like this. Oi, pui, it came like this. I threw it vertically. Doi, pui, it came like this. How should I throw it now? I should throw it at an angle. Is it so difficult to understand that I should throw it at an angle now? That angle is theta. Now, instead of throwing it vertically up, I throw it like this. So then it goes dung, 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 dung. It goes like this. You understand this? This u is known as the velocity of projection. Previously also it was velocity of projection. This theta is known as angle of projection. In the previous case, this theta was 90. That is why it was known as vertical projectile. Dung 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 dung. Now this theta is not 90, so it is pung 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 this way. Do we understand this? U is known as the velocity of projection and theta is known as the angle of projection. Now what is going to happen? It is not only going to go up, it is also going to move forward. So it will reach a maximum point. If I call this point as O, the point of projection, let me call this point as A and let me call this point as B. So it will reach a maximum height H max. It will reach a maximum height H max. It will also cover some distance on ground that is known as the horizontal range or simply range. It will stay some time in air. Ding, ding. It will stay some time in air. That time will be known as T. Time of what?
Time of flight, sir.
Time of flight. The time it remains in air. Time of flight. It will take some time to go up. Dang, 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 dang. This is time taken to go up or time of ascent. A, ascent, going up. It will take some time to come down. Dang, 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 dang. This will be known as time taken to go down
Time of descent, sir.
or time of descent. This U can be now resolved into two components. One is along X, Ux. One is along Y, Uy. How much is this Ux equal to? It is equal to U cos theta. Yes or no? How much is this Uy equal to?
U sin theta, sir.
Great. Now we are talking. So basically, what is going to happen now is that it is not only going to go up, it is also going to move forward. It will cover some distance along the ground, will also move some high. One is known as H max, the other one is known as the range. Okay, now remember, the only force acting on this body is what? It's gravitational force. And therefore, wherever it goes, there's only one force acting on this body. What is that?
Gravitational force.
Gravitational force. It is always acting downwards. And what is the value of this ping, 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 ping stuff? What is the value of acceleration due to gravity? It is G and it is downwards. Do we understand this? Acceleration due to gravity, G, is acting downwards. Whether I throw it like this, or I throw it like this, or in the last case, I'm going to throw it like this. You say, sir, how will it be a projectile? It will move along ground. I'm not throwing it from ground. I'm going to throw it from some height. So whether I throw it like this, or I throw it like this, or I throw it like this from some height, the only force acting on it is gravity, and it produces an acceleration due to gravity, which is always taken constant, which is always taken downwards. Do we understand this? The next class, we will go ahead and try to see You already know the values of time of flight, maximum height and horizontal range, yes or no? We'll go through those formulae, we'll write some important points and try to wind up this oblique projectile in the next class. So I'll see you in the next class with the topics being continued. And if you have done this beforehand, that is a great sign. Just go through those formulae so that we can speed up the process. Okay? Okay,
Thank
then.
you, sir. Okay.
Take care and I'll see you tomorrow. Bye bye.
Thank you, sir.